Viewers, welcome to part 2 of plane figures in technical drawing. We'll be discussing quadrilaterals and polygons. Now to recap from the summary of a quadrilateral from the first part of this video. A quadrilateral is a plane figure bounded by 4 straight lines or sides. And to note, a line which joins any opposite corner of the quadrilateral is called a diagonal. We have different types of quadrilaterals. We have the square, the rhombus, also known as the diamond shape, the rectangle, parallelogram, trapezium, and trapezoid. Things you should keep in mind about the square. It is bounded by 4 equal sides. All 4 angles of the square are 90 degrees each. That is, they are all right angles. And the diagonals of the square bisect at 90 degrees. A rhombus. A rhombus can also be known as the diamond shape. A rhombus has 4 angles and opposite angles are equal. That is, 2 opposite angles facing each other are equal. The angles are not all right angles unless the rhombus happens to be a square. So you can see that a square is also a type of rhombus, but its angles are all at 90 degrees. Now a rhombus has 2 angles that are less than 90 degrees and 2 angles that are greater than 90 degrees. A rectangle is a type of quadrilateral, a 4-sided polygon with 4 right angles each at 90 degrees and opposite sides which are equal and parallel to each other. The diagonals in the rectangle are equal and bisect each other. So that's it for the rectangle. A parallelogram. A parallelogram is a 4-sided polygon, which is also known as the quadrilateral, with 2 pairs of opposite sides that are parallel. Opposite sides are equal in length, and the opposite angles are also equal. Adjacent angles are supplementary, which means they add up to 180 degrees. The diagonals bisect each other, but they are not necessarily equal to each other. A trapezium. A trapezium has a pair of opposite sides which are called bases, and these sides are parallel to each other. The non-parallel sides of the trapezium are called legs. The trapezoid is similar to the trapezium, as in some countries the trapezium is referred to as a trapezoid. So the trapezoid is similar to the trapezium, and it also has parallel sides called bases and non-parallel sides which are called legs. So the internal angles in a trapezoid are often supplementary at each leg, and the diagonals can intersect but do not bisect equally unless they are symmetric. So that's it for quadrilaterals. Now we'll discuss about polygons. So a polygon, to recap, is a plane figure bounded by more than 4 straight lines or sides. And to note, the sum of the exterior angles in a polygon is 360 degrees, and the sum of interior angles in a polygon is greater than 360 degrees. And now, as you can see from the diagram, we have the parts of the polygon. So this diagram is a diagram of a regular polygon where all the sides of the polygon are of equal length. So the side which is at the bottom of the polygon is a straight line that forms the boundary of the polygon. So as I said before, all the sides are of equal length. The vertex. The vertex is the point where two sides meet, and in this regular polygon, all the internal angles formed at the vertex are equal. The interior angle, represented by x degrees in the diagram, is found inside the polygon at each vertex. It is formed between two adjacent sides. The exterior angle, represented by y degrees, is formed by one side and the extension of the adjacent side. All the exterior angles in a regular polygon are equal, and their sum is always 360 degrees. The diagonal. The diagonal is a line segment that connects one vertex to another non-adjacent vertex. The center. The center is the point that is equidistant from all vertices. That is, the center is a point where all the diagonals meet and all the diagonals are equidistant, which is equal from that point to all the vertices they are connected to. From that center point, you can inscribe a circle in the regular polygon, and that circle will touch all the sides of the regular polygon. Now, the radius. The radius of this regular polygon is the distance from the center to any vertex point. All the radii in the regular polygon are equal. Now keep in mind, when you're talking about radius, it means one distant line from the center to any vertex point. And when you're talking about radii, it means more than one distance from the center to any vertex. The apothem. The apothem is a line from the center to the midpoint of any of the sides in the regular polygon. And this apothem forms a right angle with any of the sides which it meets. Now, if you notice, you can see this abbreviation AF and also AC. Now, AF is across flats, and this means the distance between two opposite flat sides of a polygon, typically a hexagon. Now for AC, it means across corners. Now across corners is the distance from one corner, that is a vertex of the polygon, directly across to the opposite corner, that is another vertex point of the polygon. Now, a regular polygon. A regular polygon has all the sides and angles equal. And to note, the distance between two opposite faces in the regular polygon is called the diameter. Now, in the previous diagram, we talked about the radius, and if you know about circles, which we will discuss in an upcoming video, the radius is half the distance of the diameter. So the diameter is the full distance from one point of the circle to the other point of the circle, which is called the circumference. So similarly, the diameter in the regular polygon touches the two opposite sides of the regular polygon, which are parallel to each other. And as you can see, the across flat dimension, across flat is the total distance between two opposite sides of the polygon. So this is why we have here the arrow showing across flat dimension, which is also the distance of the across flat. Irregular polygon. A polygon is irregular if the sides and angles are not equal. And also for the irregular polygon, the distance between two diametrically opposed corners is called the diagonal. As you can see, this is a vertex and this is also another vertex point. So the distance between two of the vertex points is called the diagonal. So this arrow here shows the across corners dimension, which is the distance between the two vertices in the polygon. Now, a convex polygon is a fully shaped polygon which has all the angles less than 180 degrees. And on the other hand, if the polygon has a hollow shape, or if any of its angles is more than 180 degrees, it is referred to as reentrant polygon. Now we will talk about the different common polygons found in technical drawing. First is the pentagon. As you can see from the diagram, the pentagon is a polygon that is bounded by 5 sides. Pentagon also has 5 angles. Each angle in a pentagon is equal to 108 degrees. A hexagon has 6 sides and 6 angles. Each of the angles in a hexagon, that is the interior angle, is equal to 120 degrees. A heptagon is a polygon with 7 sides and 7 angles. It is less commonly called a septagon. Each interior angle of the heptagon is approximately equal to 129 degrees. An octagon is a polygon that is bounded by 8 sides and it has 8 angles, summing up to 135 degrees each. A nonagon is a polygon that is bounded by 9 sides and has 9 different angles, each approximately summing up to 140 degrees. So a nonagon is also called an enneagon. A decagon is a polygon bounded by 10 equal sides and it also has 10 angles, which each are 144 degrees. Decagon is a polygon that is bounded by 11 sides and it has 11 angles, which are approximately 147 degrees each. A dodecagon is a polygon that is bounded by 12 equal sides and it has 12 angles, each of 150 degrees. Thank you for checking out today's video, which is part 2 of plane figures. Part 3 is going to be on circles, and there we'll talk about the parts of the circles and the different types of circles we have in technical drawing. So if you like this video, please consider to give a thumbs up and subscribe to this channel so you can see more upcoming videos on the technical drawing for beginners.